I think I'm recording. Okay. So, all right. So let me go again. Number 25. I'm going to start over and see if I can do this really quickly. So this is on the homework 5.9.
Why is your recording yourself?
And what am I recording? What's that?
Why are you recording yourself?
Okay.
People are out.
Okay. I have at least 3 hockey players and some people that are out. And what I want to do is make the class accessible to them. So this is the one that I usually do G period the day before, but I'm going to do it. Yeah. So anyway, this is for those listening. This is B. So, but anyway, reviewing the homework, and where am I? Where's the top of this thing? So, so this is our homework 5.9, number 25. And let me just quickly copy it over again. And I have t over t minus 1 equals 1 over t plus 2 and plus 3 over t squared plus t minus 2, which factors to, again, we have t minus 1 times t plus 2. All right, so one more time, the restricted values for t are that t cannot equal what? 1 or negative 2. So t cannot equal 1, t cannot equal negative 2. So let's go ahead and solve this. What am I going to multiply by? Now today we're going to be doing word problems, and I need to remind you that the skills that were learned and here are also going to be used in the word problem. So anytime in the word problem we get fractions, we're going to be multiplying by the LCD to get rid of the fractions, all right? Any equations like that. So what are we going to multiply everything by here? T minus 1 and t plus 2. And because, like we said the other day, because these LCDs are so unwieldy, instead of writing them for each term, we can just kind of write them off to the side and do the multiplication in our head. So we have over here is t minus 1 times t plus 2, and t minus 1 times t plus 2 over here. And let's go ahead and, what cancels on the left-hand side of the equation? T minus 1 is gone, so we're left with t times t plus 2 equals, and what's that going to be equal to? All right, it's going to be, so we're going to multiply it by 2 numbers now, right? So the first number, okay, in the first number, what cancels is the t plus 2, right? So we're going to be left with t minus 1. And, now I'm going to not do that. And then what else do we get? What cancels on the next, on this next term? It's just going to be plus 3, correct. It's pretty much, because everything's gone, right? So the whole thing cancels with the whole thing. The denominators are the same as the LCD. So let's finish up. We have t squared plus 2t equals t plus 2. Now, once we get to this spot, a lot of times we get a little bit, I think we get a little stuck. And it's because we're lacking, we're not recognizing something. If we get stuck here, it's because we're not recognizing the type of equation it is. And the type of the equation it is dictated by that exponent 2. Or it's no longer something that we can solve by subtracting and dividing like we did in Algebra 1. This one here, because there's a squared term in it, means that it is called anyone? It's called a quadratic. And the only way that we've been solving quadratics recently is by factoring. And so for us to get it into a form that we can factor it, though, we need to get everything all together on one side. And we need to get it so that it's in order of exponents. So what I'm going to do is I'm going to move everything over to the left-hand side. So I'm going to subtract t and then subtract the 2. So what do I get now? I'm going to get a t squared plus t minus 2 is equal to 0. Now I have this thing set up in a way that I can usually that I can factor it. I'm going to put my two little parentheses here because there's only a 1 in front of the t squared. All right, I can factor this by finding two numbers that multiply to -2 and add up to +1, the middle term. And what would that be? Two numbers that
Plus 2
multiply.
and minus 2.
Yeah, +2 and -1, right?
No,
What's that?
is it the other way? No.
Because, +2 -1 multiply to -2. And notice the middle term has got a 1 in it, right? We don't write it, but it's got a 1. So 2 -1 is that +1 that we need in the middle. Does that make sense, Kate?
Yeah.
Okay, so what are my two values then? Therefore, t is going to be equal to -2, and t is equal to 1. Okay? And, this is one of those 1 in 10 cases where we need to check the domain. And what does the domain tell us about our answer? That neither of these solutions are allowed. So so they don't work, and therefore the answer, that's why the answer was, Jay, no solution.
Mr. Shepard.
Yeah.
So what if, we got two answers and only one of them wasn't, allowed?
Then the other one would be allowed.
Okay.
Correct. All right, did everyone hear that? What if only one isn't allowed and the other one is, right?
Then we just circle.
Then it would just be that one answer.
Can we do
Yep.
19?
And we could definitely do number 19. Number 19 is u over u minus 2. Plus 30 over u plus 2. Equals 9. And so LCD on this one, what is it going to be?
Two and
It's going to be u minus 2 and u plus 2.
Correct. And again, because these LCDs are so big, let's just go ahead and write them once and see if we can't carry out the multiplication. Plus 2 times u minus 2. Why do I keep doing that stuff? U minus 2. Do that on both sides. Okay, so on the first one, multiplying the first term on the left, the u, what's going to cancel is the u minus 2, right? And it leaves us with, so we still have the u in the numerator, but now we have a u plus 2, right, so far? Now, see if we can carry out the multiplication on the next one. What cancels on the 30 over u plus 2? U plus 2, leaving us with?
U minus 2.
Yes, u minus 2. And then over here on this side, we still have the 9. There's no denominator, so we have to multiply the whole thing out. Just if you remember, I don't know if you remember that u plus 2 times u minus 2 comes from u squared minus 4.
So you just
Do you remember that?
9.
Yeah, I'm just shortening it, so I'm not multiplying. You may not remember that, but you remember u plus 2 times u minus 2 comes from that difference of two squares? Okay, so let's keep going.
9u squared minus 36.
So we got u squared plus 2u plus 30u minus 60. I know this looks really nasty, but it does work, minus 36. So let's go ahead and simplify as much as we can on both sides. We put the u's together. So we got u squared plus 32u minus 60 equals the 9u squared minus 36. Now this is that time to recognize that this is not the typical kind of equation. This is a quadratic, and you're probably just sitting there going, oh, I don't want to have to factor again, but let's go ahead and do it. It's not going to be so
I
bad.
thought you subtract the 9u squared.
We can subtract the 9u squared. Okay, let's go. You want to move everything to the...
Yeah, because that's what I did, and then I just don't know.
Okay, so if the one reason I would tend to move everything to the right, is what? Does anyone know?
No.
I like to have the squared term, I want the u squared term to be positive, because only is in a positive value can we factor it simply. So, but go ahead. Let's go ahead and do that. We subtract 9u squared. We
Oh,
get,
that's what I did wrong. I did 8 instead of -8.
okay, so right now it's going to be
Okay.
negative 8u squared if I subtract 8u squared from both sides. Now I'm going to subtract, I'm also going to subtract the 36. I subtract 30, if I subtract 30, oh, why did I get this? I subtract 30, I add 36 to both sides. I'm going to get a negative 14 or something. Am I right? 28, 24.
I added. Wait. Oh yeah, 20.
Okay,
Negative 24.
negative 24.
Yeah.
Now, okay, because I want the front to be a positive, I can just multiply everything by -1, all right? And I'm going to get 8u squared
How did you get 24? Oh, okay.
minus 32u plus 24. And Tatum, what's your question?
Where did you get the 8u squared from?
Okay, because I subtracted a 9u squared from both sides.
Oh, okay.
Thank you for the question, though.
You're welcome.
Yeah, I did just kind of stick that one in there, and I was wondering if anyone.
Wait.
Thank
did
you.
What? What did you do?
I to get the 8u, I subtracted 9u from both sides.
Oh yeah.
Okay, now it's helpful to have recognized that there's a common factor here. Did anyone see it? You could still solve it, but if you divide everything by 8, it becomes much nicer very quickly. And because it's an equation, I can divide both sides by 8. And 0 divided by 8 is just 0. So it just disappears. So this is the same as u squared minus 4u plus 3 equals 0. Now, we don't always get to see those things, but if you do, it certainly gets a lot nicer, doesn't it? And then I'm going to factor, and I'm going to remember, unfortunately, that I forgot to make sure that u does not equal 2 and that u does not equal -2. Now that we're getting close to the end, I'm going, oh, I almost forgot. But let's go ahead and what do we get? Two numbers that multiply to become 3 and add up to -4.
So u minus 3, u minus 1.
Oh, it's okay. It's going to be, say it again?
U minus 3, u minus
Minus 3 minus 1. Yeah, I agree. All right, that gives us a positive. So it's going to be u minus 3, u minus 1 equals 0. Therefore, u is equal to 3, and u is equal to 1. And check your domain, make sure. Is it check? Are those allowed values?
Yeah.
Yeah. Okay. So, are you guys ready? All right.
Yeah.
Oh my God. Okay. 23. Did anyone get any of these assignments? Got questions right? Okay.
So for 23, it was weird. I did everything and I thought I did it right, and then I got my answer was 4 and -2, and then I checked the book and it's like -4.
Okay. Let's go. All right. So. I would imagine, I think I know where the problem, where you're going to, there's two places where we can make an error here. U minus 3 over, okay, having graded lots of these things from high school students, the two places where I think the flag goes up for me in terms of where you're going to make a mistake is I see a negative sign, first of all. That's always a red flag. Be careful with those things. And also I see the 2. You need to recognize that 2 is also a term. So whatever LCD I come up with, I have to multiply the 2 by also. So the LCD, you're going to get, let me factor this, is going to be u, two numbers that multiply to -6, add up to +1. U plus 3, u minus 2 would be my guess for that. Then that's right, I think, right? Yeah. Okay, therefore my LCD is going to be what?
U plus 3, u minus 3.
Okay, it's going to be that, right?
Then you can.
U plus 3 times u minus 2, u minus 2?
No, u minus 3.
No, 2.
Oh, wait. No. Yeah, I know what I did wrong.
You got it now? Do I still need to keep going?
U minus 3 and u plus 3.
All right. So all right. So the left hand side of the equation simplifies pretty nicely. So Regan, what do I have for that?
What do you mean?
For
Okay. Oh wait, no, wait. Point to it really quick.
the first term here. So when I multiply that, what do I,
Becomes u plus 3 and u minus 2.
right. So what's going to happen?
Oh, so then you have to multiply everything by that.
Right. So what happens?
So you do 5 times u minus 2 and 5 times u plus 3. And then
Okay,
you do,
but
the 5 doesn't multiply to anything, right?
so it just can't exactly. Sydney's right, right? It just cancels
But it
because
cancels out,
the
so-
denominators are the denominators are the same as LCD. So it's just going to be 5.
Yeah, so then you do 2 times u plus 3 and then 2 times u minus 2.
So
2 times u squared plus u minus 6, right?
oh, is that what you? Okay, yeah, yeah, correct. We don't have to multiply it up because it's already there. So we can write 2 times u squared plus u minus 6. Now, does everyone understand that that's the same as u plus 3 times u minus 2? Right? It's the same. And then the last thing I have is minus u minus 3 and times.
Wait, no, can't you just do negative u plus 3 already?
I could go.
Negative u plus 3 times u plus 3. Could you do u squared minus 9?
Yeah, let's go ahead and do that. So I'm going to go 5 equals 2u squared plus 2u minus 12, distribute the 2. And then I also have, let's be careful here, who said u squared minus 9? That's correct. U minus 3 times u plus 3 is u squared minus 9. Now I'm going to distribute you see how careful I am with that minus sign?
Would it work
Because-
to just like distribute it already, like just do negative u plus 3?
I think you need to be very careful with minus signs. That's all I'm saying. Because a lot of people, if you're not careful, a lot of you would have gotten a negative 9. Did you get a negative 9 on that?
No, I got a positive 9.
Well, that's pretty good. Okay, well,
Because I just distributed it first.
okay. Let's get everything together on the left-hand side. Let's go ahead and simplify things. Got 5 is equal to 2u squared minus u squared. Is this going to be a u squared plus
Wait,
2?
Where did you get the 2? Or is that supposed to be a 12?
Minus 12, correct. And that's going to be minus, and so that ends up being minus 3 here. And now what am I, there's one more step before I can start solving this.
I'll take the 5 over.
Get the 5 over to the other side. So now I've got u squared plus 2u. When I subtract the 5, I get minus 8 is equal to 0. Now it's all set equal to 0, and here's where we're going to factor it. So we're going to, you're phoning during classes and
I know, but I
helping.
understand
Where
what you're
did the 20
going
go?
over.
Oh.
All right, so all right, then factor this for me then.
Okay. You are going to get.
You could just factor it in your head. Like, you know what you're doing. Just like, so you can practice it.
4 times u minus 2. And you both set them equal to 0, and you should get negative 4 and equal to positive 2. And then you plug it back in, and you realize that you only get one solution, and u is not equal to.
Why is that?
Because you plug
You really-
it back in.
Okay, do we need to plug it in, or what did I forget to do again? The domain. What would the domain have been?
Be in 2 and negative 3.
U cannot equal 2, and u cannot equal negative 3,
so
right?
the answer is negative 4. So the answer is one solution and negative 4.
So the only answer that works is negative 4. All right? Right? Okay, are we copacetic? All right. All right, so let's go to, all right. So let's move to the word problems, okay? You're going to hold that homework for a little bit, but
Hot in here.
it really is hot in here, and I guess
Are the word problems hard?
you can turn that fan on, and then I may have to go next door and find out whether or not they.
Are the word problems hard?
No. Okay. So what I'm going to do, I'm going to do 3 word problems, and then I'm going to give you the packet so that you can try them yourself. All right. They're all relatively similar. So and there's mostly 2 types of problems. Before we start, so this is So we're going to talk about, this is section 5.8 and 5.9, word problems. And before we start, one of the, this was hard. One class has got like half of international students, and they really needed this. As in word problems, the word is often interpreted as what? As equal sign, right? And the other term that we see a lot is the word of. What does that mean?
Times.
Yeah, multiply. So let's see if we can do a simple one first. I'm going to say 16. If I say 16 is 3/8 of 5/10 of a number. Now these are word problems. I know oftentimes in science and in math we often say write down all the given information, find the equation, things like this. These problems that you're going to be doing, and there's several of them, you're just going to go and just write it straight out. So let's see if you guys, can you look at that and tell me what would be the equation? 16. All right, go ahead, Juan. 16 equals
Is it 3 over 8
3/8
times
times.
5 over 10?
Oh, I should have wrote the word of. I'm sorry. That should have said of. But yeah, right. Times 5/10
And then
times
times x.
x. Exactly right. All right. And so, at this point, it just becomes algebra.
Times x, right?
All right. And we can reduce a little bit the 5 and the 10. There's already 1/2. That's pretty much it. So we get 16 equals 3/16 times x, multiply both sides by 16 over 3, and we get a big number. I don't know what it is. Now, for the homework, okay, for the problems you're going to be doing today, you will need a calculator. So if you have one, great. If you don't, I have this. I have these little cheapy solar 4-function calculators here. But 16 times 16, yeah, I'd just rather not have phones out right now because they seem to be a big distraction. Yes, right now. Okay, 16 times 16 is what? 16 times 16, I think it's something like 256. So that's it. So what's one type of word problem that you can have that's just kind of direct translation. The next type of word problem, and I
Wait, can't you simplify that?
I don't think so. Is that right? No.
Oh, no, you can't. It's not like it.
Does I don't think so. Okay. So the next problems, okay, these are the ones that you have to. Oh, okay. Before we get to the next one, let's make sure that we know how do we convert from percent to decimal. Okay, you can put it over 100, correct? Or say, okay, for instance, if I have 35%, that is the same as 35 over 100, which is also the same as 0.35. So you could also move the decimal 2 places to the left to deal with that. So on percent problems, like here's one that says 30 is 20% of 30% of a number.
So 30 equals
30 is equal to
20 times 20%, 20 over 100 times
So-
30 over 100
yes, we could write it that way. 20 over 100.
times 30 over 100 times x, like 30 over 100x.
All right, there you go. And so you could either do it that way, or you could have written it as 30 equals 0.2 times 0.30 times x. Either way. All right, and in this case, what you need is that's going to be 3 equals 0.6x. Divide both sides by 0.6. And you get
What did the x equals
30%. Oh, 30. Sorry about that.
Is
I,
that
I don't know why that zero's not. Okay, so it's going to be 30 over 0.6, which is going to be something like, I don't know, a bigger number. What is it? It's going to be 6. It's 6 over 300.
500? It's right. Oh wait, I did 30. Wait, sorry. It's 50.
It's 50. All right. So x equals 50. All right. Now the next two next two problems, and we're done. Just 2 more problems. Watch, and then we'll move into the word problem thing. Okay. So the next one, you're gonna like this one. Okay. So,
I thought x equals 500.
all righty. Here we go. Here's another example. Lauren,
I know, but I did it the fraction way.
wishes to obtain 800 milliliters of a 7% solution of boric acid by mixing 4% a 4% and 12% solution. How much of each should she use?
Okay, we just went from an easy ones.
What is that boric acid?
Okay. So the idea is she's trying to get a 7% solution. So she's mixing something that's 4%, which is less strong, with a much stronger solution, and somehow trying to meet it in the middle, right? So by mixing a lower percentage and a higher percentage, she's going to try to get that 7%. So let me show you how we're going to do these. You don't have to organize it my way, but one of the things, before we go in, oh, it's still up there from yesterday. One of the things that we need to recognize is just kind of is how this works. If I have 500 milliliters of a 12% acid solution, is there a way that I can figure out how much acid that actually is?
What?
Oh, I'm just saying here. Let's go off to the side here and just see if we can remind ourselves what this is asking. If I have a 12% of a 500 milliliters of a solution, and 12% of it is acid, how much acid do I actually have? What would I do?
12 over 100 is 600.
Exactly. Just multiply 12%. So think of what I would say. I'm going 12% of the 500 milliliters. And the word "of" means multiply, right? So we're going to multiply the percent times the quantity to get the actual quantity of acid that's in there. And what we can do is we can relate that quantity of acid in a special way that allows us to solve for the quantity. Let me show you how. So just kind of follow along. You're going to have one problem very much like this. And so I'm going to create a 3x4 grid. So I was going to go... and 2 of the lines represent what I'm mixing, and the last line represents my final solution. So I have the 2 things. So this is the 2 things that I'm mixing. I'm going to put here. And then my final line will be the final solution. So what are the two things that I'm mixing? What two solutions am I mixing?
7, 4, and 12.
Okay, I'm mixing a 4% and a 12%. And in the end, my final is going to be all right, is that 7% solution. So what I'm going to do is this. I'm going to put the solution, quantity of solution, times the percent, and this is going to give me the amount of boric acid.
Wait,
Okay, just give me, once I start putting the numbers in, it'll make more sense.
quantity of solution times percent.
The quantity of the solution. So how much 4% solution am I putting in here?
800
Ooh,
milliliters.
how much 4% is going in there? How much final solution do I have?
800.
800. So where does that go? Is down here. All right? Okay, now I want to ask again. I go, how much of the 4% solution is in this thing?
No idea.
We have no idea. And what is the name? What is the mathematical name for no idea? X. Thank you. So,
What?
thank you. Okay, well said.
No,
So,
I actually had no idea.
now the tricky part is the second one. So, if I know that I have 800 total, and X is the 4% solution, there's a way to express the amount of 12% solution using the 800 and the X. How'd you guys know that? I didn't tell you. I was hinting at it. Okay, so 800 minus X, yeah. So I take away how much 4%, and that's how much 12%'s got to be there. Someone in the other class said, what if I wanted to choose 12% as being X? Would that be okay? And then yeah. Right. If I make the 1200 X, when I solve for X, I'm getting the 12% solution. Yes.
How did you get 800x?
800 minus X.
Oh.
Okay, and so the percent of the solution, I'm just going to go, I'll write 0.4 here, and 0.12 here, and 0.07 here.
Wouldn't it be 0.04?
Say again?
Wouldn't it be 0.04?
Yeah.
You're absolutely right. Thank you. Wow, you're good. Okay, so 0.04. Thank you. So, and so what we can do is we get an expression for the amount of acid for each one. So this is going to be 0.04x. I'm going to run out of space on this guy there, but I'll make my box a little bigger.
Y times x.
I think
0.12 times 800 minus x. I had to extend that a little bit. And then my last piece is going to be 800 times 0.07. I'm almost done, guys. I know this is not terribly fun, especially those of you that are taking chemistry and having a splendid experience with it. I'm sure this looks terrible, but it's not so bad. Hopefully in a minute. Okay, so, all right, okay, so what I need you to think about is I'm mixing this quantity plus this quantity to get this quantity of acid, all right? So we're going to use an expression of the quantity of acid to create an equation that's going to allow me to
You
solve
just
for
said it
X.
equals to 800.
800 times.
0.07, exactly. Okay, so, and this is where you need a calculator. So if you have a calculator, this is helpful. Is we get 0.04x plus 0.12 times 800 minus x, and equals. I'm gonna write it this way: it's 0.07 times 800. Now, what's that?
Equals to something each side off to the
Yes, what I'm going to do is I'll It's going to be on a YouTube. It's going to be YouTube. All right. So, so if you, I don't know if you guys remember, but one of the things that we were doing, and one of the things that we are doing to simplify expressions like this, a decimal is also considered a fraction. So there can be a way of multiplying each of these numbers. There's a number I can multiply each of these by to simplify this. There's 3 terms here, right? Now, if I express the percent as a fraction 4 over 100, it might be a little bit more obvious. This is 4 over 100. This is 12 over 100. This is 7 over 100. What's the LCD if I wrote this as a fraction? 100. What would happen if I multiplied each of these numbers by 100? What would it be a little bit nicer? Yeah, they'd be whole numbers. So here is an application of what we've done in the chapter. I can rewrite this as 4x plus 12
That doesn't make sense. Why would you even change it?
times 800 times minus 12 times x
If the denominator was 100, wouldn't it?
equals 7 times 800.
But you don't have to do anything to 800.
But then that thing's so big.
So yeah, it's a little bit of
Do we have to do that?
well, as opposed to what?
Doing it without that?
You don't have to do that.
Wait, what's the answer?
You could have kept it as a decimal. The final answer is x equals 500.
Wait, Mr. Shai, I don't get why you need to change it to the like 0.04 and 0.12 in the first place. We're just gonna change it back.
You don't know until you get to the equation that you can do that, right? Yes. Yeah, you could. All right. So, okay. Yes. Take a brain break, and we'll pause for now. I'll let me finish. I'm gonna finish solving this just so we have this solved. But I think you can trust me to do that on my own, right? I guess.
Yeah, it's okay.
It's okay. I'm gonna get. Did anyone solve it yet? I'm gonna get 89600
Yeah, I do.
minus 8x equals 5600. 8x equals negative 8x equals 4,000. Negative 4,000, and therefore
Where's the, like,
x is going to be 4,000 divided by 8, which is 500
Like
milliliters. And if x is 500 milliliters, 800 minus x equals 300 milliliters, which is the 12%. So 500 milliliters of 4% and 300 milliliters of 12%. Pause. Okay, so let me just, there's a problem here. Investment problems and mixture problems are pretty much the same thing, except instead of dealing with mixtures instead of dealing with mixtures, you're just dealing with investments. And so with an investment too, you have a certain quantity, and you're promised a certain percentage of that quantity at the end of a certain term. So what I'm going to do is I'll just set this up in a similar way that we did the mixtures, and we'll treat it pretty much the same as a mixture problem. So again, I'll go ahead and make my box to organize the information. And so instead of solutions, I'm going to get, I'm going to write amount invested. And just like the solutions, though, I do have a percent return or an interest rate, as they call it. And then at the end, I get a certain quantity of what they call interest.
What does that say in the second box? No.
So the second box says amount invested. This one here.
Yeah.
So we have two funds.
Why is it different every time?
Yeah.
Wait, say again.
Why is it different every time?
Well, this one's not a boric acid problem.
How do we know like how to write it every time?
Well, I want you to kind of see in the sense that I know that seems kind of strange to say that an investment is very much like a mixture problem, but this is like the solution that we have, the original quantity that we have. And then when I look about that, when I say percent, well, this is how we figure out how much. It's a percent of the money that you invest that gives you the interest rate that you get. So if you invested $100 at 10%, that would mean at the end of a year, typically, you would get 10 extra dollars to add to your 100. So what did you do? You take the amount, the 100 you invested, and you multiply it by the 10%, and then you write the interest as you earn $10. All right? So now you have 110.
Is the graph? Is like the chart way the easiest way to do it?
You can use it, you don't have to use it. I just feel that at the most basic level, it's probably it's easiest to understand it doing this way. But I think that some of you might find it just as easy to write. Okay, I know I've got so much money invested at a certain rate, and just write down the expression. You could do that, but let's just go ahead and you could. I'm saying that some of you may be able to go right from here, right to the original, right to the final equation. But let's just take our time with it. So the two investments that we have, one is at 6.5, and the other one is going to be at 8%. And then we have a total down here, just like we did with the just as we did with the boric acid thing. So. What is the total? What boxes can be filled based on the material the information that we have in the paragraph? For instance, where would I put the $129? Okay, in which box? The top, bottom, the top, middle, or bottom? The bottom. Yeah, that's the total amount of money made. How much is? What is the total amount invested? Is $1,800, and I'm just going to go ahead and write that here, right? Is that the total? And so, and Tasha, you're good at this. How much do we invest at 6.5?
You just do divide 1,800 like.
I was looking for the answer. I have no idea.
Oh.
Why? Because that's what the question's asking, right?
Yeah.
All right. So do you have any idea?
No.
No. Okay. So we'll call it X. And based on the solution problem, same thing. If I have a total of 1,800 and I just spent X on 6.5, what would be an expression for the 8%? Exactly. 1,800 minus X. Okay. So we're almost there. We got 6.5%. Do you want to write as a decimal or a fraction?
How
That-
do we know it? Like, how do we know for 8% then it's 800, 1,800
Yeah,
minus
whatever
X?
did 6.5 is.
Say again?
For how do you know that you put the 1,800 minus X at the 8% not 6.5?
Isn't it 0.65?
Okay, you could. All right, that was a question someone asked in the other class. What if I put X for the 8% and then 1,800 minus X for the 6.5? Believe it or not, that works too. It's just that X, if you put X for 8%, when you solve for X, you're going to get the amount of money that went in at 8%. The way it is now, when I solve the equation, x is going to be equal to the 6.5%. Do you want me to switch it just to prove my point, or you're good? Okay, so an expression for the interest of that 6.5 is going to be 0.065 times x. Why did I even put parentheses around there? Doesn't really need it. X, and then 0.08 times 1800 minus x. Ran out of space. Okay, now in a very, very similar way that we did with the solutions, I have this much interest being made from this investment, this much from this investment, and this represents the total. So how does that look for an equation? This is an expression, this is the code for how much interest I made at 6.5, the 6.5 fund, and this is the 8% fund. So the total interest for the 6.5% fund and the 8% fund should equal our 129. Does that make sense? All right? Very much like the solution thing, right? Where you have this mixed with this, it gives me the total mixture. So let's go ahead and write our equation. And what can I multiply by to get to simplify it if I want to? Don't have to. Okay. But I got 0.065 x plus 0.08 times 1800 minus x equals 129. Okay, and if you want to just keep it in decimal form, we can do that. Would you like to do that, Kate? Sure. Well, you were wondering, you go, do we have to multiply by 100? So I'm that's one. So, but we don't have to. So let's go ahead and I'll show you. So this one, it doesn't necessarily make it much easier, to be honest with you. I guess I think you're right. Doesn't necessarily make it easier. By multiplying everything by 100, doesn't necessarily make everything easier, but it does get rid of the decimal.
Wait, wouldn't we multiply it by thousands?
Yes, because of the 6.5, right. But let's go ahead and not. All right, so what is 0.08 times 1800? Let's get this done real quick here, guys. Well, I'll tell you what. Let me finish it. All right? You don't. This is at this point, this is just algebra. What I'd like you to do, though, right now is I'd like to hand this out, this packet out. And so, could someone do this for me? And go ahead and get started on this packet as soon as you get it. And this is your homework also. So, Jay? Do you find yourself asking that question frequently? Okay, let me finish. I'm going to finish this problem, but I'd like you guys to get started on this right away. So, I'm going to pause you guys for a sec. So, the final answer, after I finish all that math, is going to be at 6%. We have 1,000. Get that from the solving for x at the bottom. And then what I do, take the 1,800 minus that 1,000 for the $800 that was invested at the 8%.
Yeah, or just multiply both sides by 7, so then like multiply that.
One other thing.
And so it's 2x equals.
One other thing that I want to add is on substituting.
Yeah, it says.
Okay, the chapter's not on substituting. That was chapter 3.
But then why is it on the paper?
84,
and then divide by 2. So it's 40.
is a little hint on one of these questions here. Okay, how many people have gotten to question 4.5, even though that's really supposed to be just 4? I just, for the benefit of those people doing this at home and you too, there was some questions on this, but let me just remind you that this is, again, related to the chapter. Did anyone find the 2 equations that are expressed by this 4.5 or question 4? Yes.
I know one of them's going to be x plus y equals 25.
And that's exactly right. So x plus y is equal to 25. And then they say the reciprocals of these two numbers is equal to 1/6. What does that look like? What's the reciprocal of x?
1 over x.
So we have 1 over x plus 1 over y equals 1 over 6. Yes? So remind me, what was one of the things we did with fractional equations?
Find the least common denominator.
And we multiply everything by the least common denominator. In this case, it's going to be what? 6 x y. So because it's small, we could I'll write 6xy on each of these. And let's see if we can reduce. We're going to get the x's canceling on the first term, gives me 6y. The y cancels on the next term, gives me 6x. And the 6 cancels on the last term, giving me xy. Now, you still may be stuck, but what I want you to think about is, how do we solve two equations with two unknowns? We can do elimination, but this one won't work for elimination. There's another way we can solve two equations with two variables, and it starts with the letter S. A substitution, someone said, right? So what would I substitute?
Times the x and the y by 6. Or negative 6. On the other thing.
You could divide everything by, oh yeah, but I think it might be easier to take this top equation and solve for either x or y. So if I solve it for x, say, I get x equals 25 minus y. And I could plug this in, and it's not necessarily going to make life huge. But remember that there are two places where we have an x. If you plug that value in, you should be able to grind out the x value. Let me just double check. I think we're good on. Okay. I would like you to figure out how to substitute a value in.
No, but the answer is 150 equals xy. How are we supposed to find the actual problem?
You don't know how to, if you plug in 25 minus y.
No, I did the whole thing. So then it's 150 minus 6y plus 6y equals xy. 6y's cancel out. 150 equals xy. What is it like?
Okay, all right. How many? Okay, there shouldn't be any more x's once you've substituted it in.
No, because the answer is
But I-
xy.
No, I got 150 equals 25y minus y squared.
It's not xy. It's 25 minus y times y.
Did you really multiply 36 and
Okay, did you plug in?
Don't.
I'll plug in for you. Watch.
It's the 9.
Do you see what you did wrong?
9 goes into 36.
You can't say it's equal to xy, Kate, because x shouldn't even be
No,
there.
I know, but you didn't finish the problem.
I need you guys to be able. I would rather not.
If it's 25 minus y is x, and there's another y, just distribute the y, like.
I'm just gonna. I'll go ahead and substitute it in.
The answer is 81.
This is so weird. Like,
Really?
oh, I see it.
What is it on?
All right. I mean, you distribute.
Oh, but then you can simplify it.
You distribute. It's a quadratic, Kate. You set it to 0. You factor it. Okay. I don't want to do the whole thing for you because, guys, if I do this whole thing for you, then you take it on the test. It's not going to work. So anyway, I'm going to stop on this. Yeah. This. I will say number 8 is probably going to be